Hello everyone. Yes, hope you guys are fine there. This video is created for those of us who did not attend the first lesson of correlation. So here we just start by defining the word correlation. We say that correlation is the relationship between two or more variables under consideration. Then a set of paired observation from two variables is called a bivariate distribution. This is called a bivariate. The word bi means two, and variate means something that keeps on changing. Okay, so that's why we are saying that in the bivariate distribution, a change in one variable matched by a similar proportional change in the other variable. The technique used to measure the degree of association or relationship is what we are calling the correlation. So correlation is simply just the relationship that is between two or more variables. Now, before calculating the degree of relationship, it is often useful to plot paired observation on a scatter diagram. So before you do anything, we always plot the paired observations on a scatter diagram. So a scatter diagram here is a graphical representation. It's a graphical representation of the relationship between two variables. So here we are saying that if x and y are the two variables under consideration, then plotting y against the x gives a scatter diagram. The variable plotted on the horizontal is called the independent variable, meaning it can exist without the variable that is plotted on the vertical axis, while that one on the vertical axis is called the dependent variable. Okay, we have now types of correlation. Perfect, perfect positive correlation. We are going to look at scatter diagrams, and we shall be talking about all these types of correlation in terms of the way the scatter diagram appears. So for perfect correlation, we shall have our scatter diagram. Of course, as usual, it's going to be a plot on the graph. So what does it mean? It will be looking like that. Okay, so we shall be plotting, but as you plot, your lines, your points are going to appear to be like in a line. Your points are going to be appearing to be in a line. We have another type of correlation. We have perfect negative correlation. Perfect negative correlation. Now scatter diagram. Now a scatter diagram, you just plot and you leave it just like the way the name suggests. So when you plot your scatter diagram, it will take this shape here. When you plot your scatter diagram, it is going to take that shape there, and from our coordinate geometry of O level, we know that if we plot our points and then they take those points, this line will always have a negative gradient. This line will always have a positive gradient. So for this case here, we shall also use that analogy. Now that our points are taking this direction and you can see them aligned in one line, we shall say that these points here have a perfect positive correlation, and these points which are aligned sloping this side, they will have a negative perfect correlation or perfect negative correlation. Then we have another type of correlation. This is just positive. Now remember, whatever I have here, these are types of scatter diagrams which you may come up with. There is no need. Actually, a scatter diagram, you don't join the points. Correlation. Positive correlation, we shall have our axis, that we have that. Okay. So this is our y and this is our x. So if we are to have a scatter diagram which has points, when you plot which are in this form, you can see. So here you can look at the trend of our points. The trend of our points is actually going like this. So our points are actually taking this trend here. And you can see that they are not in a straight line. So we look at the trend of our points. Which trend are they taking? And then here we make a conclusion and say, since they face this side, it is a positive correlation. Then we have another type, is a negative correlation. We are going to plot our scatter diagram, and if points be appearing like this, and if appear like this, if the trend of our points is in that direction, there we say that this type of correlation is a negative one. You can see that the points here are not in a straight line like this one's up. So we make a conclusion that basing on the trend which is being taken by these points, they have a negative correlation. Then there is another type of zero correlation. Zero or no correlation. Zero or no correlation. So for this case here, zero or no correlation, we are going to, if we happen to plot our scatter diagram and we end up with a circular shape or a rectangular shape, just know that this type of correlation is a zero correlation. Or if we can't plot and define this, we can find a circular thing here. So we shall have, if we plot up like a circle, such a way that they form something like a circle, like the way you see this type of correlation is relation between the two variables, let's say x and y. There is no correlation for this case. Okay, so this is about the scatter diagram. So scatter diagrams are going to be of these forms. They are going to be of 5 types of scatter diagrams here. Okay, let's see. When we plot our scatter diagrams, we can come up with this type of correlation, which is perfect positive or perfect negative, or positive correlation, or we can come up with a negative correlation, or we can come up with a zero correlation. Next we have to look at example. What are we going to do? In our question is saying draw a scatter diagram for the. So there we have our graph paper, which is there. So we are going to draw the axis because we have to draw the graph paper. So I have that is the y-axis, and I'm going to draw the x. Okay, there we are. So we have to demarcate, our graph I'm going to take after 2, so I make a demarcation after 2 centimeters. I make a demarcation, my 0, have my 2, 4, I have here 6, I have here 8, I have here 10, I have here 12, I have here 14, I have 16, I have 18. Then here axis, we are also plotting on the vertical axis here. Plot, have my 0, have 2, taking a scale of 2 because you can see here. On the x, our maximum value is 10 there, and in the y, my maximum value is actually 13. So if I happen to take a scale of 2, it is going to fit very well. So this is the x, the y, and this is I have 20. So can we now start plotting? Yes, we can now start plotting. So from here, the first pair is 1, 5. So we have to plot 1, 5. 1 is here, and 5 is up here. So 1, 5 is a point that is here. Okay. The next one is a point which is 2, 4. 2, 4, 2, 4, 2, 4 is here. You can see that. The next one is a point which is 3, 7. 3, 7, 3 is here, and then 7 is a point which is somewhere here, that is 3, 7. The next point is 4, 6. 4, 6, 4, 6 is the next point. 4, 6 is the next point. Good. Then we are going to the next point with 6, 8. 6, 8 is this point here. The next point, this is done like they will plot coordinates on the Cartesian plane. So the next point to plot is 7, 11. 7, 11. 7, 11. 7 is in the middle here, and 11, 11. Right. Then the next point there we have 9, 13. 9, 13, 9 is here, 13 is a point that is there. The next point is, the last one is 10, 12. 10, 10, 12, 12 is here. Yes, 12 is there. So this is how our scatter diagram is looking like. So this is the scatter diagram. Okay, and we are done with our scatter diagram. So what does it mean? Let's go back here. You can observe that this came first. This one here, we have here the values of x, and this is the value of y. Now what comes first is always the independent. Variable, and what follows next. For that reason, now this we say that up here, when you look at slide 1, we say that the variable plotted on the horizontal axis is called independent variable, while that plotted on the vertical axis is called the dependent variable. So what comes first here in our table is always the independent variable, and it will be plotted on the horizontal axis. Then the dependent variable, which is this one here, is always going to be plotted on the vertical axis. Okay, so that is our number 1 question about correlation. Okay, our graph is here. If you have to come back here and look at our graph, you can observe that since this is taking this direction, you can see that these points are scattered in this direction, And from here, when you look at the shape which we have, which is of the same is when you try to compare these points which we have plotted here. So what does this mean? It means there is a positive basing on how our points are moving. We now predict this trend to be actually this, and this means there is a positive correlation now between X and Y. Why am I using X and Y? Because here we have been given X and Y. So that's the comment, there is a positive correlation. There is a positive correlation between X and Y. Okay, and we are done commenting. We are done. So the next question is here. They are saying that the local bakery would like to be able to predict demand, sales for their bread from the amount they spend on advertising it. Okay, and this was shown in the table below. So we have this table here. We have this is advertising, and we have this as sale. What comes here in the first column, at times they will be in the first row here for this case, but if it is in terms of columns, what comes first is always independent variable, variable, and this which comes second is always a dependent variable. So that means this is plotted on the horizontal axis, and this is plotted on the vertical axis. Okay, so the next question here, or the question is now asking us to, plot the scatter diagram, and then we comment on the correlation. So like the way we did in the first one, we had this question here, draw a scatter diagram for the following. So we had to draw this as the scatter diagram. Please, this is a scatter diagram. The name suggests it clearly that this is a scatter diagram. Okay, so we are going to do the same for this one here. We are going to do the same for this one here. Okay, so we are going to. So we have our graph here. Okay, we have now our graph here. There. I have my drawing our axis there. So I'm gonna have my writing tool, question and C. So what is it? The question saying we need to plot sales against advertisement, because sales is our dependent variable and the advertisement is an independent variable. So when you look at advertising, the biggest value is 10, and when you look at sales, the biggest value is let me see here, I'm seeing 150. Sales, the biggest value is 150. So we go back to our our slide for plotting. So I'm supposed to have to plot here. So I can come up with a scale. We know that now sales, the biggest value was 10. So I can have a demarcation of 2. I'm not very accurate. To make sure you're accurate there on your graph. This is technology now at work. So I'm going to have a demarcation. This is 0, Here I have 2, here I have 4, here this will be 12, this will be 14, this will be 16, this will be 18 here. Then up here, I'm also going to have a demarcation of 2. Now, what is, if we are to label, we have here advertising. This is advertising. Okay, it is in euros. Okay, then we have sales, euros. Okay, so we start sale. When it comes to sales, the biggest value is 150. So if I can start from 20, it can work well on my graph here. If I put here 20, this will be my 40. Okay, step of 20. So I will have here my 6, and I have 220. Okay, so we are plotting sales against advertising. So we start our coordinates. This is the usual way we are going to plot. The first point to be plotted is 340. We go to our graph. 3 is actually lying here, and 40 is just here. So this is the point, 340, and we are done. We go to the next point, 360. 3 and 60 is just there. You can see. The next one is 500. 5 and a point. Then the next one is 6 and 90. 6, then 99. 7 is in the middle here. Along this, we need to allocate where 110 is. Now 110 is there, because this is 100, this is 120, it lies there in the middle. The next one is here, and 130 is up here. Yeah, this is 8 and 130. Then we have 6. Got you there. Okay, so we have the second last, 7 and 120. 7 and 120. You can see that it's already plotted, so no problem there. We are going to the last one. This is 10 and 150. 10 and 150. So this is how our scatter diagram appears. This is how our scatter diagram now appears, okay, after being plotted. So when you look at the trend of our points, it is seeming to be like these other points here, okay, like that. So when you happen to look at these diagrams here, these are types of correlations. So when you look at this, all of these ones, all these drawings, okay, the next one is actually here, and this type here. So when you look at all of these types, you will see that the shape which you have drawn is of this nature. The shape which you have drawn is of this nature. So what does this mean? It simply means that the type of correlation that we have here, because these are our scattered points and they are taking this direction. So it simply means that the type of correlation in the comment. So the type of correlation, because I have said we plot, so we have done the plotting and we have to comment. So you have to comment and say there is a positive. There is a positive correlation. There is a positive advertising and sales. So, take it as an example. You have your commodities and you don't advertise. What will happen? No one will buy. So if at all you have your commodities and you advertise, what will happen to the sales? The sales will go high. So the same thing happens here. So what does that mean? It simply tells us that there is a positive correlation. So when one variable is increasing, when you put in more money in advertising, you will realize more sales, and that is why we call this positive correlation. Next, let me give you a number that you are going to try. So there we are. This is the number that we have to work on. Yes, this is the number that we have to work on. There is a question which should be added here. It should be seen that you have to comment also. Comment on the relationship. Okay, that one I've added it. So after plotting your scatter diagram, please be able to comment on the relationship between math and physics. The next lesson that is going to follow next, keep with me. Let us move together. In the next lesson, we are going to look at how to draw a line through these points here. How to draw a line through these plotted points. Okay, and that line is called the line of best fit. Please keep with me as we move to the next one. Thank you very much.